My name's Rhett Jesse, and today we're going to talk about the Metrix Digital Proximity System. What we're going to demonstrate is how the proximity system works in a tight situation. Let me describe what I mean. In a normal proximity probe system, you want to be at least one probe tip diameter away from the probe tip in order not to have any interference. So this outside diameter on this metal disc I have, you can't have any metal close to that probe tip that will be right there. So you want to be outside that circle. So it's at least 19 millimeters or 25 millimeters with some competitive probes. But the Metrix beam is actually pretty narrow already, so we need 19. Well, what we can do is we can reconfigure the digital proximity system for a tight situation. And here we have 0.5 inches or 12.7 millimeters, and that's really narrow for an 8 millimeter probe. But we can actually still get the full linear range out of this system. So that's what we're gonna see. We're actually gonna see how the probe performs in a tight situation. Now, we've already showed you that it works in a linear fashion for a 5-meter system looking at a 4140 target. So we've already done that. What we're gonna do now is we're gonna reconfigure the DPS software, put the fixture on, and run a curve and see if we can still make that linear. So let's just go ahead and put on the fixture. I'll go ahead and back this out. What we mean by a tight view, you can see when you look at this fixture that the probe is very close to the metal on the sides, and that's what we mean by tight view. So when I put it in the static calibrator, I'm not only going to have a tight view on the sides, but I'll also be measuring the gap as I move the target away from the probe. I have my micrometer set for 0 mils and I have the probe right against it. And then I'll tighten this up so the probe stays in contact with the target. This is just my initial setup. Then what I'm going to do is I'm going to put the tight view flush with the probe tip so that way they're parallel. And I know they're set at exactly the same plane. So when I start to back out or I start to move the micrometer, the target's going to move away and we're going to be in a very tight situation with regard to the probe tip. The metal will be all the way around it and we'll see how linear it is. Before I do that, I have to change the configuration from what's right now is in the digital proximity system. So I'm going to start the software and I have it connected via the USB cable, which is normally covered by the DIN rail mounting, but I've removed that and now I'm connected to it. You know, before I change the configuration, let's just run it and see how it behaves. I think it's of interest to show you what it looks like if you didn't change the configuration. How linear is it? So let's go ahead and run it first without changing the configuration. So we'll just go to the tuning and verification step, and let's just go ahead and take data. And we'll take data every 10 mils, and let's just see what we get. So we'll go ahead and move the disc out 10. I'm gonna hold it so it doesn't rotate. All right, so I'm at 10 mils. I'll go ahead and say get. And I'll go ahead and say, do not show me the message again because I know I have to move it before I hit get each time. So as it fills in, we'll get the data and we'll change it every 10 mils and we'll just look at the results. And what you'll see is it won't be linear. So I'll go ahead and do every 10 mils. So you get what you can see from the curve, it's no longer straight. You can see the incremental scale factor is moving downward. So instead of having a nice straight line, we have this arching line, and that's not good. We'd like to see a nice linear characteristic. What's interesting about it though is this is a very good characteristic because Metrix has a pretty narrow beam coming out of their probe tip. And when you look at it, you think, wow, we're well within specification out to 40, almost 50 mils, and that's actually pretty good. But what we can do is we can actually make it a lot better by reconfiguring it for the TightView situation. And that's what we're going to do. So we're going to go back to that home page, and we're going to reconfigure it for TightView, and that's what I'm going to go ahead and do right now. So we'll go to the probe series, and we'll select MX8030 TightView, and we'll pick counter bore, and we'll say we'll go 10 to 90 still on the range. Everything else remains the same, still a 4140 target, and we'll send the configuration. Then after we send this configuration, we'll do a verification and see if everything is linear, or to see if we've made an improvement. Now what we're going to do is do a tuning and verification step to make sure it's working. In this case, we're not going to tune it just because the way the TightView system works is it's tight in the machine. It's unlike you're going to have a fixture. So we've made it for a tight situation. That's what you know you have. Now we're just going to test for linearity, see how close we are. I'm also going to demonstrate, if there is any issues, we'll do a custom calibration. So we'll see how that works. The first thing we're going to do is we're going to go ahead and move our micrometer out to 10 mils. And I hold the fixture steady so that way it doesn't move. I want to keep it parallel with the probe tip so that way they stay in a nice straight line. So I'm at 10, and I'll say get. It gives me the warning. I'll go ahead and turn that off. And it gives you that warning each time. I know I have to move the fixture before I hit get. So just remember that when you're doing this yourself. And I move this in 10 mil increments, and when we're done, we'll look at our results. All right, this is our last data point, and that's all the way out to 100 mils in this tight situation. It's doubtful you'll ever be out that far. But what's nice is that it works pretty well. You can see from the results that we'd like to be between 190 and 210. Now, the API doesn't actually address this situation, where, what are the specifications for this tight situation? Typically, you'd like to have no metal near the tip. But in this case, because of the machine's construction, we do have metal near it. So we get a nice linear characteristic. So we look at it, we say, hey, if we wanted it better, could we make it better? And the answer is yes, we can. And to do that, I'm just going to show you we can. It's very linear for how tight we are, but let's see if we can make it better. And that's the nice thing about the digital proximity system. We can. So let's go ahead and do a custom calibration. So to do that, we just hit yes. After it performs its custom calibration, we'll redo the verification to see if it's improved. Now, most people would say what we already had was good enough, but we just want to do it. So we'll go ahead and move the micrometer back to 10. So we'll go to 0, verify we're still at 0. We're at 10, and we'll go ahead and say get. So it's now reconfigured because we did a custom calibration. And we have 1.021 volts, so that's good. Now we'll go ahead and do that every 10 mils, and we'll do what we've done before and just look at the results. All right, this is the last data point, and you can see that after the custom calibration, it did improve the curve. This is very adequate for a TightView situation. So this is a demonstration of the Metrix digital proximity system in the TightView situation. Thank you very much.